Alright, welcome back to the channel, fellow developers. Today we're cutting through the hype and getting down to the practicalities of AI coding tools. This isn't about replacing us or handing off our entire project to a black box. It's about giving us new, more efficient tools for our belt. Think of it like choosing the right specialized wrenches and power tools for a complex engineering project. You're still the engineer, you still understand the blueprint, but now you have instruments that allow you to build better, faster, and smarter. Our goal here isn't to outsource the work, but to understand these nuances so we can truly level up our craft. So what exactly are AI coding tools? At their core, these are applications built on machine learning algorithms, often large language models or LLMs, specifically trained on vast amounts of code. They learn patterns, best practices, and common structures. You might be thinking, is this just fancy autocomplete? Well, it's a lot more intelligent than that. These tools predict, suggest, and even generate entire blocks of code based on context and intent, effectively acting as incredibly knowledgeable pair programmers, ready to assist whenever you need them. One of the biggest categories we see is code generation. This is where the ACI can create boilerplate, scaffold out functions, or even complete entire methods based on a natural language prompt or existing code context. Picture a moment where you're setting up a new API endpoint, and instead of manually writing all the CRUD operations and their associated routes, the AI can generate a significant portion of that structure for you. It's about reducing repetitive tasks, freeing you up to focus on the unique business logic. Then we have tools focused on refactoring and optimizations. These AI assistants can analyze your existing codebase, suggest improvements for clarity, performance, or adherence to coding standards. They're like having an expert eye constantly scanning your work, pointing out areas where a loop could be more efficient, or suggesting a clearer variable name. It helps maintain code quality, makes your projects easier to manage, and ultimately saves countless hours in the long run. Finally, there's testing and debugging. AI tools can help generate unit tests, identify potential bugs or vulnerabilities before runtime, and even suggest fixes for existing issues. This isn't just about finding errors. It's about building more robust, reliable software from the ground up, reducing technical debt, and improving the user experience. Now that we've got a handle on the fundamentals, let's dive deeper into how these tools stack up. Next up, we'll do a feature-by-feature comparison of some of the top AI coding tools out there. Alright, developers, in our last session, we laid the groundwork, understanding what AI coding tools are at a fundamental level. Now, it's time to get pragmatic. Just like choosing the right specialized wrenches and power tools for a complex engineering project, you need to understand the nuances of each tool, not just blindly pick one. We're diving deep into a feature-by-feature comparison across the different types of AI coding tools out there. First up, let's talk about the bedrock, language and ecosystem foundations. A tool is only as useful as its ability to speak your preferred programming languages, whether that's Python, JavaScript, Java, or C#. We'll look at their framework compatibility. Does it understand React or Spring Boot? Alongside critical OS support and cloud integrations. This is foundational, determining if a tool can even fit into your existing tech stack. Once that foundation is set, how smoothly does it integrate into your daily grind? This is about seamless IDE integration. Your integrated development environment is your command center, and a good AI tool should feel like a native extension. We'll explore which popular IDEs like VS Code or IntelliJ are supported, the availability of dedicated plugins or extensions, and how effectively they provide real-time suggestions and auto-completion right where you're coding. Does it enhance your flow or fight against it? And this brings us to what truly differentiates a good tool from a great one, the actual quality and accuracy of its suggestions. This is where we separate the smart power tools from the blunt instruments. Many of you might be concerned about the proliferation of lazy or verbose AI-generated content, and rightly so. I've seen teams struggle when they blindly adopt tools that churn out boilerplate without understanding context. Here, we evaluate code quality analysis features, the relevance and precision of suggestions, error detection, and even test case generation support. Does it make you smarter or just faster at writing garbage? Beyond just getting code, how much customization and control do you actually have? Can you truly tailor the AI to your specific coding style? Your team's conventions? We'll look at configuration options for model parameters, support for custom style guides, and whether you can choose between local or cloud-based processing. Crucially, we'll examine data privacy and security settings, giving you the reins over your intellectual property and sensitive code. Finally, No tool exists in a vacuum. How easy is it to pick up? This covers the learning curve and community support. We'll assess the ease of onboarding, the quality of documentation, and the availability of learning resources. Beyond that, the strength of the community forum and developer support can be a lifesaver when you hit a snag. Understanding these comparisons is crucial, but knowing how to apply them to your specific coding headaches is the next step. Let's explore how each tool solves real-world problems in our next section. Alright, so we've compared these incredible AI tools feature by feature. But what does that actually mean for your daily grind? How do they solve those common coding headaches that make you want to pull your hair out? Let's dive into some practical, beginner-friendly examples. First up, let's talk about boilerplate code. That repetitive, often tedious setup code you write for every new component, every data model, it's a time sink. AI code generation tools are your first specialized wrench here. They can instantly scaffold common structures, like a React component with state and props, or a basic API endpoint. It's not about outsourcing your thought process. It's about accelerating the groundwork, freeing you to focus on the unique logic that truly matters. Next, the ever-present challenge of debugging. You might be thinking, can AI really find my bugs? If this feels familiar, picture a moment where you've spent hours hunting for a subtle typo or an off-by-one error in a massive codebase. I've seen teams slash debugging time significantly because AI tools can analyze your code, highlight potential issues, and even suggest fixes. They act like a second pair of expert eyes, quickly pointing you towards the problem areas so you can understand and implement the solution yourself rather than blindly copy-pasting. Then there's automated test generation. Writing comprehensive unit and integration tests is crucial for code reliability, but it's often deprioritized due to time constraints. Here, AI tools become an indispensable power tool, helping you generate robust test cases based on your function signatures and existing code logic. They can even suggest edge cases you might have missed. This doesn't replace your understanding of test-driven development. It augments your ability to achieve higher code coverage and maintain confidence in your changes. Finally, let's tackle documentation. We all know we should document our code, but who has the time? AI tools can significantly streamline this process by generating initial doc strings for functions, outlining project READMEs, or even explaining complex code blocks in natural language. Think of it as a smart assistant drafting the first version, allowing you to review, refine, and add crucial context without starting from a blank page. It transforms documentation from a chore into a collaborative editing process. So you see how these AI tools aren't just fancy gadgets. They are precisely those specialized wrenches and power tools we discussed for a complex engineering project. They help you build better, faster, and smarter, not by doing the work for you, but by empowering you to understand the nuances and execute with precision. Ready to pick up these tools and get them integrated into your workflow? Let's talk about installation and integration next. All right, developers, we've discussed the why and what of AI coding tools. Now, let's get hands-on. Think of it like a complex engineering project. You choose the right specialized wrenches and power tools, understanding their nuances to build better, faster, and smarter. The same goes for setting up your AI. We need to do it mindfully to truly level up our code, not just outsource the work. Before installing, let's prep your coding workbench. Ensure your IDE, VS Code, or IntelliJ is updated. Verify any required language extensions are active. And a stable internet connection is vital. These small steps lay a solid foundation, preventing common hiccups and ensuring compatibility with your new AI Copilot. Now for installation. For most AI tools, this mirrors adding any standard IDE extension. We'll cover the general steps for tools like GitHub Copilot or Tab9. Navigate to your IDE's extensions marketplace, sidebar in versus code, or settings, then plugins in IntelliJ. Search, click, install, and crucially, restart your IDE. It's that simple to get the wrench into your toolkit, ready for tunings. Once installed, most AI tools require initial configuration. This securely connects the tool and defines its operation. Often, it involves authenticating with GitHub or pasting an API key. You might be thinking, why bother with all this setup? Well, like calibrating a new power tool, these settings help the AI understand your context and coding style. I've seen teams get generic, low-quality suggestions that slow them down when they skip this. Proper configuration makes the AI a valuable partner. While basic installation is straightforward, specific IDEs have unique nuances. For VS Code users, extension enabling is automatic, but always check settings for language servers or suggestion triggers. In IntelliJ, post-plugin installation, find the Tools Settings panel under Preferences Tools Greater Than. Here, fine-tune aspects like suggestion delay, excluded file types, or proxy settings.
This ensures the AI feels truly native to your environment. With your AI tool installed and configured, it's maiden voyage time. Open a code file, start typing, and observe the suggestions. But critically, especially with concerns about AI-generated spam, do not blindly accept output. Your developer skills are paramount. Review the code, understand why it's suggested, and assess its alignment with your project's architecture. Is it efficient? Secure? Readable? Treating AI suggestions as a starting point for critical evaluation, not a final solution, is key to responsible integration. Next, we'll explore best practices for preserving and strengthening your core coding skills. Alright, you've got your AI coding tools installed and integrated, feeling the power. But here's where we get real about using them effectively, without turning into what some on Reddit call lazy developers. This isn't about outsourcing your brain. It's about smart amplifications. Think of AI tools not as a replacement for your hands, but as a sophisticated, specialized wrench in your complex engineering project toolkit. Just as you'd use that wrench to better understand the engine's mechanics, AI is a profound learning aid. Use it to ask why a piece of code works, or to explore alternative implementations, rather than simply accepting the first suggestion. You might be thinking, but if AI generates the code, how do I truly learn? This shifts your role. Instead of writing every line, you become the ultimate code auditor. You need to critically review every snippet, trace its execution path, and identify potential issues or inefficiencies. In real systems, this shows up when you're reviewing a pull request, where 80% of the code was AI generated, and your human insight is crucial for catching the subtle edge cases or architectural misalignments the AI missed. Now, avoiding over-reliance is paramount. It's easy to fall into the autopilot trap, letting AI handle repetitive tasks without truly understanding the underlying logic. That's how coding muscle memory degrades. Challenge yourself. Sometimes, deliberately solve a problem without AI assistance first. Identify your skill gaps, and then bring the AI in as a tutor, not just a copier. This leads us to deliberate practice. To truly preserve and enhance your skills, you need to actively engage with coding challenges, build small projects from scratch, and refactor existing code manually, even when AI could do it faster. This isn't about shunning AI. It's about making your foundational skills so robust that AI becomes an accelerator, not a dependency. Your unique architectural thinking, complex problem-solving abilities, and ethical considerations are the human edge AI can't replicate. And understanding that distinction, that mindful integration, will be key as we next dive into the specific pros, cons, and trade-offs of when to use each tool. We've integrated AI mindfully, but choosing the right tool is next. Not all AI coding tools are equal. Understanding their core differences is key. Broadly, they fall into two categories: generative AI, creating new code, and predictive AI, assisting by completing or refactoring. Each has unique strengths and crucial trade-offs. You might be thinking, which one is for my project? That's what we'll explore now. Generative AI excels in sheer speed. Need a boilerplate or a quick draft? These tools rapidly churn out code, overcoming blank page paralysis and reducing repetitive tasks. But caveats exist.
Output can be verbose, irrelevant, and often demands heavy refactoring.
Blindly pasting generated code invites technical debt and security vulnerabilities.
It always demands critical review.
Then there's predictive AI, often IDE integrated.
Think smart autocompletion, bug fixes, refactoring suggestions. These are your specialized wrenches and power tools for a complex engineering project. They don't outsource the build. They help you build better, faster, smarter by understanding your existing codebase, their strength, precision, and context. In real systems, this shows up when a predictive tool highlights a potential race condition or suggests a more efficient data structure. The challenge? Over-reliance, where you accept suggestions without true understanding, degrading essential skills. So, when to pick which? For greenfield projects or quick scaffolds, generative AI boosts productivity if you're a vigilant editor. For maintaining codebases, debugging, or learning new patterns, predictive AI shines. It augments your thought process, offering guidance, not wholesale solutions. Many combine both, generative for a first draft, predictive to refine quality. It's about leveraging their distinct strengths for the right situations. Ultimately, your choice depends on project needs, team maturity, and personal learning goals. Prioritize rapid iteration or precise, context-aware assistance, AI as a crutch, or a powerful assistant for complex problem solving? The most effective approach finds the right tool for your unique workflow. However, even with the right tools, pitfalls exist. Next, we'll dive into navigating AI's common traps: quality, security, and pervasive misconceptions. We've explored AI tool power, but now, pitfalls. Many developers, rightfully, caution against low-quality, verbose, or lazy AI-generated code. This isn't fear-mongering. It's about being a savvy developer who critically evaluates every tool. Ignoring these issues invites more problems than solutions. One immediate pitfall is inaccurate suggestions, or hallucinations. AI models, trained on vast datasets, don't understand context like a human. This can lead to code that's syntactically correct but logically flawed, overly verbose, or inefficient. You might be thinking, but it looks right. That's precisely the danger. Then there are security implications. AI-generated code can inadvertently introduce vulnerabilities, replicating patterns with known exploits, or missing critical security practices. Integrating untested AI snippets into production without thorough review is essentially rolling the dice with your users, data, and system integrity. The biggest pitfall, a constant Reddit concern, is blindly accepting AI output. It's like a specialized power tool, an impact wrench, but never learning why or when a hand wrench is better. You just hit the trigger. Picture a junior developer pasting an AI solution without truly grasping implications, causing subtle, hard-to-trace bugs. Your responsibility as the human developer never disappears. This blind acceptance quickly leads to over-reliance and a loss of crucial context. Stop analyzing the why behind the code, and you lose sight of architectural patterns and underlying algorithms. This degrades your core problem-solving skills, turning you into a copy-paster, not an engineer. It strips away the deeper learning from wrestling with problems yourself. So how do we navigate this? Responsible AI use. Treat AI tools like a knowledgeable but sometimes overzealous junior developer. They offer suggestions, boilerplates, and new approaches, but you are the senior architect. Every line needs your critical review, understanding, and approval. Use it to enhance understanding and accelerate learning, not to delegate your thinking. Ultimately, AI should sharpen, not dull, your developer instincts. Make it a practice to debug AI-generated code, refactor for clarity, and challenge its assumptions. This proactive approach ensures you're leveraging AI as a powerful assistant while cultivating expertise. Up next, we'll explore how to extend the power of these tools, looking at their ecosystems and communities. Okay, so we've looked at some powerful AI coding tools, and we've navigated their potential pitfalls. But just like a master engineer doesn't stop at a basic wrench set, a truly effective developer needs to understand the full ecosystem of their AI tools. Think of it this way. The core AI coding tools we've discussed are your foundational power tools, incredibly capable, right out of the box. But for a complex engineering project, you need those highly specialized wrenches and custom attachments. That's exactly what extensions and plugins offer, allowing you to tailor these AI tools to your specific tech stack, your team's workflow, and even your personal coding style. Then there are the communities. You might be thinking, another forum to sift through? But these aren't just echo chambers. I've seen teams leverage GitHub discussions and Discord channels, not for simply copying AI answers, but for deep dives into why an AI suggestion might be suboptimal for their specific framework, or to collaboratively debug a tricky prompt. It's where you find nuanced insights and truly learn, rather than just delegate. And let's not overlook the official documentation and community-driven tutorials. These are your comprehensive manuals and practical guides. They're crucial for understanding the, how, and why behind configuring a new module, or integrating an AI tool into a CI/CD pipeline, ensuring you're using it effectively, not just haphazardly pasting codes. For those ready to go deeper, many of these tools also support advanced modules and even custom model fine-tuning. This allows you to essentially build your own specialized AI tools, trained on your codebase's unique patterns and conventions. It's about making the AI truly an extension of your team's expertise, not a generic, off-the-shelf solution. But here's the critical part: engaging with this ecosystem responsibly. It's about seeking quality solutions, contributing genuine insights, and verifying everything. This mindful engagement is how we elevate our craft. Instead of just flooding the internet with low-effort AI output, it's how we keep our skills sharp and make sure we're truly understanding the code, which, conveniently, leads us right into our next section, a quick skill check. Alright, we've covered a lot about picking the right tools, like choosing the perfect specialized wrench for a specific part of your engineering project. But just like you wouldn't blindly tighten every bolt, using AI-generated code requires a sharp, critical eye. It's not about outsourcing your brain, but about enhancing it. So let's do a quick skill check to see how well you're internalizing these principles. Here's the scenario. An AI coding assistant generates a complex function for your project. What's your most responsible next steps? Ready? Take a moment to think about it. It's easy to feel the pressure of speed, especially when you're on a deadline, right? You might be thinking, the AI just wrote it, so it must be good. But that's exactly where we need to apply our developer toolkit. The correct answer is, thoroughly review the code for correctness, efficiency, security vulnerabilities, and adherence to project standards, understanding why it works before integrating. This is the core of what we've been discussing. Just getting a new power tool doesn't mean you understand the physics of what it's doing, or if it's the right fit for your specific material. Picture a moment where a junior developer, rushing to meet a sprint goal, blindly copies an AI-generated snippet into a critical path, only to find out later it had a subtle security flaw or a memory leak that caused production outages. That's the kind of headache we're trying to avoid. It's about leveraging AI as a powerful assistant, a sophisticated wrench, not a replacement for your engineering judgment. You need to own the code, even if AI helped write it. This mindful approach prevents the lazy AI content problem many developers are rightly concerned about, ensuring your skills aren't degrading, but evolving. We've journeyed through the landscape of AI coding tools, exploring everything from fundamental concepts to best practices for mindful integration. We've seen how these tools, much like specialized wrenches and power tools, can help us build better, faster, and smarter when understood and wielded with precision, rather than simply outsourcing the entire job. But the conversation doesn't end here. The role of AI in our craft is still evolving, and many of you, rightly so, have concerns. You might be thinking, how do we use these without losing our edge? Or, how do we maintain quality amidst the flood of AI-generated content? These are vital questions. So as we look ahead, what's your take on the future? How do you envision AI shaping the developer's role, not just for beginners, but for seasoned engineers too? Are we heading towards augmented mastery or a dependency that dulls our essential skills? Thank you so much for watching and for being a part of this deep dive. If this video sparked a new thought or confirmed a long-held suspicion, please hit that like button. Drop your perspectives, your predictions, or even your challenges with AI coding tools in the comments below. Your insights truly enrich our community. Don't forget to subscribe and hit the bell for more developer-focused content. And for the complete guide, strategies, and even more tool comparisons, check out our full playbook. The link is right there in the description.